Hello, everyone. Hello, everyone. My name is Kuan-Jung Huang, and this work is done by me and Adrian Staub at UMass Amherst. And the study investigates what influences the prevalence of misreading and why. Misreading is ubiquitous in everyday life. To the extent that misreading phenomena are systematic, understanding them provides us the insight into the interplay between bottom-up input and top-down knowledge. In the previous decades, there have been several empirical studies showing that readers' interpretation of a sentence can systematically deviate from the literal sentence. For example, readers sometimes autocorrect who is given what when the literal sentence doesn't fit the semantic world knowledge. Another example is that readers very frequently fail to notice repetition of the or omission of the in a written sentence. In this current study, we investigate another specific misreading phenomena, like the following example. Readers occasionally read the word order wrong, not noticing the transposition. And this was first demonstrated by Miraud and colleagues and is termed the transposed word effect. The above misreading phenomena have been demonstrated in different paradigms like grammaticality judgment task or direct probe of interpretation task. In our lab, the main task we have been using is a natural reading task where participants are unpredictably probed the existence of an arrow after having read a sentence. So why do people fail to notice word transposition? One possible account is parallel word processing and noisy position coding as proposed by Miraud and colleagues. As can be seen in this figure, the simultaneous activation of multiple adjacent words makes it possible for a word in the later position to be recognized before a word in an early position. And the noisy position representation enables a word in a later position to be assigned to an earlier position. However, in two very recent studies, including our own, we have shown that the transposed word effects exist even when each word in a sentence is presented strictly serially. And this is true for both Chinese and English materials. So these findings suggest that parallel word processing is not required for the transposed word effect. We therefore embrace another possible account, the rational inference over a noisy channel account. And in this study, we further evaluate this second account. The rational approach assumes a task performer to be an ideal observer who utilize all information available to them. This includes their top-down knowledge. In the case of sentence reading, it is assumed that experienced readers are well aware of various possible noise during the communication process. The goal of sentence comprehension, therefore, is not to decode every perceived word literally, but to recover the underlying intended message from noisy utterances. This can be formularized as the following simple base rules. Readers calculate the conditional probability of intended message given the perceived message by considering A, how probable the intended message is, and B, how likely the intended message has been corrupted into the perceived message. For the transposed word effect, the perceived transposed sequence of two words can be attributed to some movement arrows and can be denoised back into a grammatical sequence if the intended message is highly probable and if the required editing is simple. So given a transposed word sentence like, "We should him put to bed soon," the probability of misreading it as a grammatical sequence is proportional to the ratio of the posterior probability of the non-literal message over the literal message. And when other factors are carefully controlled for, the higher the prior probability the intended message is, the more likely it should be that a reader will misread the sequence, the input as a grammatical sequence. So this is one clear prediction by the rational inference account for misreading. And note that the prior probability of the intended message very likely is not the prior probability of the whole presented sentence. We have shown elsewhere that readers do not wait all the way till they finish the whole sentence to start the inference process. And you can ask me more about the time course of rational inference during Q&A. So the goal of the current study is to test the prediction about the role of prior probability in misreading. Note that it is unclear yet exactly what statistics readers use as the prior probability for rational inference. One possible way to operationalize prior probability of a string of words is to measure the conditional probability of the last word in a string given its preceding context. And this can be done in a closed task where participants are asked to continue a sentence fragment. The more frequent response people give, the higher conditional probability that word is, and in turn, the higher probability of the whole string is. In experiment 1, we manipulate conditional probability to see if this vector influences the rate of transposition detection. And as a reminder, the paradigm we used for measuring transposition detection rate is to unpredictably probe participants whether there was anything wrong in the previously read sentence. Our items were from Pili and colleagues, which is a large-scale closed norming study. From each sentence of theirs, we picked 2 close responses, and we added the same ending context for each sentence pair. One is the modal response most people gave, and the other is a response very few people gave. This is our critical manipulation. The sentences we selected can be further categorized into 2 subgroups based on their syntactic categories of the transposed words. One subgroup involved transposing a determiner and a noun, and the other subgroup involved transposing an adjective and a noun. But we will present the aggregated results here because the results for the 2 subgroups are very similar. So here are the results for experiment 1. First, participants answered the comprehension questions for the fillers very accurately. And here are the rates of failure to detect transposition in the high and low conditions. The error rates for the grammatical conditions reflect false alarms, which are very low. Critically, the generalized linear mixed effect model showed that we failed to find a difference between the high and low conditions. This suggests that readers are not fully rational decoders who utilize all information available to them. One possible explanation for the null effect is that due to the attention or memory constraints, readers are not able to effectively utilize the full preceding context available to them for rational inference. The alternative hypothesis thus is that readers only use statistics of local information to perform rational inference. That is, instead of considering the prior probability of the whole string seen so far, they consider only the prior probability of the string of a few words seen before and at the transposition arrow. This variable can be easily quantified by the frequency of co-occurrence of these words in some very large linguistic corpus, which is also known as the n-gram frequency. Indeed, in another previous experiment from my unpublished masters, we saw preliminary evidence for the effect of n-gram frequency on transposition detection rates. There, we originally manipulated the syntactic structure of the transposed words to test a hypothesis irrelevant to the current one. This syntactic manipulation is irrelevant to the research question here, but within each of the 6 syntactic conditions, we had 20 unique items whose n-gram frequency naturally varied across a wide range. This does allow us to do a simple correlational analysis between local unground frequency and transposition detection rates. The transposition in this experiment always occur between the third and fourth words. So for example, between put and him in this sentence. So the x-axis here is the log transformed trigram frequency of the second, third, and fourth words in the sentence. To give a concrete example, the trigram frequency of the stimulus, we should him put to bed soon, is the frequency of the co-occurrence of should put him in a large linguistic corpus called Coca corpus. And the y-axis is the rate of failure to detect the transposition. Each dot plotted here is an item's log trigram frequency and its mean error rate. And each both sides here is the mean log trigram frequency for each syntactic condition and the mean error rate of that condition. Again, syntactic manipulation is irrelevant here, but most importantly, what we see are high correlations between log trigram frequency and the detection failure. This is so both across experimental conditions and within experimental conditions. So the strong correlation hints a potential effect of local unground frequency on misreading. Given the preliminary evidence in experiment 2, we experimentally manipulate the local unground frequency to operationalize prior probability. For each item, we had a pair of string of words differing in only their last word. We carefully selected the pairs such that the group level unigram and bigram frequency were matched between the two groups, while the group level trigram and foregram frequency differ. Again, the frequency stats was from Coca corpus, which is a 1 billion word linguistic corpus. And we transposed the last two words in the phrases to see if those with high trigram frequency evade readers' detection more easily. And one final note is that in experiment 2, we also manipulated other types of written errors, including the omission error and repetition error. But due to the time constraint, I won't present the whole results here. I'll only present the transposition results. And the results for experiment 2 are here. The rates of failure to detect transposition in the high and low conditions. The generalized linear mixed effect model showed that we failed to find a significant difference between the high and low conditions, and this was surprising to us. However, looking at the absolute error rates, we found that in both conditions, they were really high. In fact, this might be the most illusory transposition items of any reported in the literature. So what made the items in both conditions in experiment 2 so illusory? Although we failed to find a difference in experiment 2, when plotting the condition mean error rates against the condition mean log trigram frequency across all the experiments from our lab, there appears to be a strong indication of a relationship between log trigram frequency and failure of detection of transposition. This is particularly so when we compare conditions of similar syntactic structures across experiments. Also notable is that while our two critical conditions in the experiment 2 differ in their log trigram frequency, both their mean trigram frequency were on the very high end of the scale. We therefore hesitate to strongly conclude that there was no effect of trigram frequency on misreading, but instead we tentatively suggest that the null effect in experiment 2 might be due to a seeding effect of trigram frequency. So to summarize this study, in experiment 1, we operationalized prior probability as conditional probability of the last words in the string, given its full preceding context. We failed to find evidence of this effect on error detection rate. The finding that available information is not effectively utilized suggests that reading is not a fully rational process, and possible reasons for bounded rationality include memory or attention constraints. In experiment 2, we operationalized prior probability as frequency of co-occurrence of 3 words surrounding the transposed words, but again, we failed to find evidence of this effect. However, the absolute error rate in both conditions were really high, And when compared across conditions, across experiments, we still saw a hint of trigram frequency effect. We therefore need to run a third experiment where the mean log trigram frequency of the high and low conditions can approximately lie around 2 and around 5 to avoid a ceiling effect. If we find a trigram frequency effect there, the results will provide strong evidence for mental storage of large chunks of linguistics representation and will lend support for a bounded rational inference account for misreading and for reading in general. And this experiment 3 is currently underway, and we hope to share the results really soon. Thanks for your listening, and we thank the following people and NSF for supporting our experiments. And I'll take questions now. Thank you.